What's up, bubbies? Welcome back to the channel. I'm just sitting in the dark, in the dungeon. This is where I do the good work. This is where I do the great work from the darkness. Let's do some VESC scripting. So we're VESC scripting. We're in the VESC tool. I've clicked over here, down on the bottom left, on the VESC dev tools. Then I've clicked up here on LISP, and I've got my script in here. So this is the script that I'm writing for my BBSHD. It's kind of a bug stuck in my bug zapper. Rest in peace, buddy. So let's just run through this script quick. I did a video yesterday, and I kind of demonstrated what it's doing a little bit, but I'll just run through the script and show you what it's doing. So this is a script I've been writing for my BBSHD. So it's a mid-drive e-bike motor. And so I've talked about this a million times, but it's a little bit tricky to put a mid-drive on a bicycle because the bicycle drivetrain, you know, sometimes there's slack in the drivetrain from all of those like ratcheting one-way clutch kind of components. So that can be a challenge. And then just getting the motor to start up smoothly and start moving the chainring smoothly and engage the drivetrain in such a way where it's nice and smooth and it's not like damaging to the bicycle drivetrain and, you know, components. It can be challenging with VESC, it seems. So VESC is it's a open source platform for motor controllers, so we're using it for my e-bike here. So I'm writing a script to control my e-bike's motor controller. So we're in VESC, we're writing a script. So let's talk about what this thing's doing. Sorry guys, I gotta like give the context here at the beginning, or else people have no idea what's going on. But we're swan diving into the deep stuff right here. So here's my script. So this is LISP VM or something as a scripting language. So let's talk about what's going on here. Can I zoom this in? Let's zoom it. Let's zoom it in, buddy. There we go. Zoom out. There we go. Let's just. Oh, there we go. All right. All right. So here we are in my script. Hopefully you can see that. All right. So up here, I've got some and so what this script does, I did a video on this yesterday, but basically when you first hit the throttle, it gently engages the drivetrain. I'm in my mid-drive, so the chainring is going to start spinning just very, very gently with just a little bit of current, just to get the motor going and to get that chain engaged and the bicycle drivetrain engaged. Right, so that's why we want this freewheeling. So this is kind of like the freewheeling current that I'm applying right now. This is the number that represents that. And then so I'm defining like a percentage of my throttle where the freewheeling should start. So I've got it set up right now so that when I hit the throttle and it's still in the throttle deadband, it's going to engage the drivetrain so that once you hit the throttle and you continue pressing the throttle beyond the deadband and then the motor starts, the idea is that like by the time your throttle gets out of that deadband, the motor have already engaged and then it should be ready to just take off, right? So I'm probably going to change that. That's just how I've implemented it so far. So let's talk a little bit more about what I have currently before I talk about what I'm going to change. So we've got this stop RPM. So this is the RPM. The freewheeling should just stop. Okay, so since you're just using a little bit of current, that current is only going to be able to spin the motor so much, right? And when you're actually on the bike, a small amount of current, like it'll keep the chainring kind of like spinning and going, but and it might help you coast a little bit and feel like you're coasting, but it's not going to be enough current to like propel the bike, make it like continue going for a long period of time. This freewheeling current, you know, it'll generally speaking, it could maybe maintain like 10 miles an hour or something. But if you hit the brakes, the freewheeling current isn't enough torque to keep the bike moving, right? And then so when the RPM of the motor drops below the stop RPM, that is when the freewheeling stops. So it's kind of like when the motor can no longer move where we consider that like going, then the freewheeling will stop, right? Because we don't want the motor to be trying to move when it just doesn't have the torque to like physically move at all. Like if you're completely stopping the bike and you're only giving it like an amp, it's only 50 watts or whatever. It's not enough to move the bike. So we don't want to be giving it a whole lot of power like after you've stopped, right? We just want the freewheeling to cut out. So then I am looking at the throttle a little bit just to see if the throttle is engaged and if the throttle isn't engaged, so we can I'm using this ADC channel 0 is ADC 1. So that's where my throttle is mapped in VESC is ADC 1. So that is the ADC channel 0, and that I'm using that in this update throttle function that I have right here that runs in a loop, and it just calls, it defines this throttle value, and then it calls this get ADC decoded function, passes in the ADC channel to that function call, and then that gives us back the throttle, like the value that the throttle is currently at in this variable, right? So then we can check if that throttle value is greater than my input deadband, which I've defined right here. By default, it's 15% in VESC is the input deadband. So that means that you can hit your throttle 15% before it starts doing anything, right? And that's just for kind of like safety reasons. But so what I'm doing here is I'm looking at the throttle, getting that from ADC, and then I'm checking is the throttle value above the deadband, and from that we can tell if the throttle is making the bike go or not. Okay, so that's what I'm using the stop RPM method for. ADC channel, or the stop RPM, these are variables. ADC channel variable, and then this input deadband variable we're using in here as part of this update throttle logic. So then I have a couple, so then I define a variable here, just like the motor current that's going to the motor. At some point, I think I was reading that, but I don't even know if I am anymore. Is that an unused variable? I think we can just get rid of that, because I don't think I'm using it anymore. So we're going to clean up my script, get rid of that. Oops. Save that. All right. So then if we keep going down here, I've got a couple variables that I declare state. So the throttle engage, we already talked about that. And then freewheeling. So it's whether or not the freewheeling in the script is like running. All right. So we talked about this update throttle function. So here's an update freewheeling function. So when this function gets called, it comes in, and then so if it's not freewheeling, so freewheeling equals 0, then it's going to come in here and it's going to check if the throttle engaged equals 0, and so this is like one big and right here. So it's checking to make sure that these two expressions are true. So if the throttle engaged equals 0, so if that means if the throttle is not engaged and the throttle value is greater than or equal to the start freewheel throttle value. So that's another, this right here, the start freewheel throttle value, I've defined that at the top, right? So if we come in here, let's just read this. So if we're not freewheeling, it's going to check if the throttle engaged is 0, so if the throttle is not engaged, and then the throttle value is greater than or equal to the start freewheel throttle value, it's going to start freewheeling. So that just checks if it should start freewheeling based on the throttle value. And right now I'm using it to engage the drivetrain in the deadband of the throttle kind of before the throttle actually starts making the motor go, so that when it does get out of that deadband, like the chainring is already just like spinning a little bit and there's no jerkiness. Okay, so that's what that check does, is kind of checks to see if it should start it based on the throttle being in the deadband. So then right here it defines the variable RPM. It calls get RPM. That's part of VESC, the scripting of VESC, we can call this get RPM thing. So then that will save the current RPM of the motor into this variable here, and then so we can use that down here. So if we're currently freewheeling, so if freewheeling equals 1, it's going to come in here and check if the RPM is less than or equal to the stop RPM, then it's going to set freewheeling to 0 or stop the freewheeling because the RPM is less than the stop RPM. But so if this conditional right here, this if that's false, it's going to skip this and it's going to go down here and it's going to say, okay, well, the RPM is greater than the stop RPM, so we can continue the freewheeling, right? Or start freewheeling. Like this is, I might have to change that. I wrote this, like I'm just kind of like throwing this script together. So this is all subject to change. I'm just kind of showing you what's going on right now, right? So then right here, there's a little bit of code. So this is the code that ultimately like sends the current to the motor right here. So at the end of this update freewheeling function, after I've done all of this logic to like decide whether or not, like, are we freewheeling or not, right? So then it's going to get to this part of the code and it's going to say, okay, so if we're freewheeling, then it's going to set the current relative to that minimum current that I defined back up here. So minimum current. So here's minimum current. I've defined this right here, and here is the start freewheel throttle value that I mentioned a moment ago. So these are just kind of like some values that I've defined up at the top as kind of configuration variables that you might have to adjust or play around with to get things, working smoothly. So that's basically the part where it's actually making the motor go. Is this line right here? It's like it checks if we're freewheeling. If freewheeling is 1, it's going to set the current to that current that we want. And then this other number, VESC has some stuff built into it, like some timeouts and stuff. When you're running the motor from a script, you have to keep saying in the script to go, 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 or else VESC will stop. This is kind of a safety feature. So this timeout right here, apparently, this is kind of hard to explain. I don't entirely understand it, but that timeout right there, I need to make that longer than this sleep doing in the main. So this is the main loop of my thread. So this is just defining functions and the variables up here. This isn't actually doing anything. It's just defining these functions. So then this is in this main loop. This is where I actually call those functions and execute that code from. So as this script is evaluated, it defines all those functions. They don't actually execute, but then it gets down here, and then this is a loop right here, the main loop of my script. So this is just going to loop forever. It's just always going to be going. As soon as the flip key turns on, this script is going to start up, and it's going to start running this in a loop forever. It's going to update the throttle, so it's going to read the throttle and get that state from the voltage from the throttle to figure out whether the throttle is, being pressed or not, right? Whether we should start up the freewheeling based on the throttle or whatever. And then there's that update freewheeling function right here. So that's just kind of the logic that kind of drives the freewheeling and turns it on or off depending on the state of the e-bike and the throttle and all of that. So that update freewheeling, it is actually driving the motor here. And what might actually make more sense is just to write a function that's like apply current or something, right? And to separate that out a little bit. So I'm just going to refactor this code quick. I'm going to move this out of this. Okay. So we refactored that a little bit. So in this update freewheeling method, it's going to run some logic, and then it's going to check all of these different things and decide should freewheeling be going or not, right? So that's update freewheeling. And then I've got this separate method here, this function apply current. So that is what actually runs the freewheeling and applies the current. Okay, so I just kind of clean that up a little bit. So we're going to save that. But yeah, so this is the main loop right here, and I just showed you the whole thing. So it's running in a loop. So it runs. So this loop runs 100 times a second. Because this sleep command right here, if I told it to sleep 1, that would sleep for a second. So if I told it sleep 0.1, that would be 1/10 of a second. And then 0.01 is 100th of a second, right? So it's going to loop, it's going to update the throttle, update the freewheeling, and it's going to apply the current, and then sleep for 100th of a second, and then it's going to just do that in a loop all the time. And that's the script currently, right? It took a while to explain that. So what I want to do here is we're going to just script one thing really quick. And so what I'm noticing when I apply the freewheeling current is it's just kind of applied all at once, right? Like when freewheeling starts, it just like, boom, it just goes. And it's applying all of that freewheeling current all at once. But I think what I want, because it can still be a little bit jerky and rough, if all of a sudden it's just like, like a couple like amps coming out of nowhere. Right, so what I want to do is I'm going to declare a variable that keeps track of when freewheeling starts, okay? And so this is going to be a state variable. And I just like to keep these separate just for my own kind of, keeping things separate. There's no concept of like config variables and state variables and LISP. That's just kind of me. So freewheeling start. Okay, so I've declared a freewheeling start variable. So this, and I'm going to add a comment here. This is the date time when freewheeling started. Okay, and then I'm going to define another one, define freewheeling current. I'm going to initialize it to 0. And so that is how much freewheeling current is being applied. And then we're going to define one more freewheeling ramp seconds. Let's just make it like half a second. Alright, so I'm going to initialize it to 0.5. So that just represents half a second. How many seconds to ramp up freewheeling current? Alright, so what I want to happen, so when freewheeling starts, we want to keep track of when it started. Okay, so in here, we're going to do one of these guys, progging. And that just lets us put more than one expression in here. This LISP programming language is a little bit confusing. Syntax, we got to put everything in parentheses and stuff. So whenever we define freewheeling 1, or when we're trying the freewheeling on, we also want to define that freewheeling start to get, what is it? Get time? What is it? Systime? Let's see here. VESC, LISP, systime. Right, so we're going to define freewheeling start to the system time so that we can keep track of when the freewheeling started. Okay, and so we're going to go and we're going to find the other places where freewheeling starts, and we're going to do that same thing. So now, in each of the spots where freewheeling starts, it's keeping track of what time the freewheeling started. Okay? So now we want to calculate how much current to apply with the freewheeling based on how long has it been since the freewheeling started. Okay? So leave a comment kind of explaining what's going on here. Let's zoom it in, buddies. Okay, so whoa. Okay. So what we're going to do here is we got to figure out how many seconds has it been since freewheeling started. So define secs since freewheel start, and then we are going to call the secs since function, and then pass in freewheeling start, that variable that we've defined up here when freewheeling started. Right? So what we're doing here is we're defining this variable, seconds since freewheeling start. Let's just make this consistent. Seconds since freewheeling start, kind of a long variable name. And then we're calling the second since function to calculate how long has it been, how many seconds has it been since freewheeling started. We're saving it, that value, in this. So then back at the top, we've got, so the freewheeling current. So this is what, so freewheeling current and then freewheeling ramp seconds. Right? So what we want to do is we want to calculate the freewheeling current. So we're going to define freewheeling current, and it's going to be seconds since freewheeling start divided by the freewheeling start seconds. So let's zoom out so I can see what's going on here. So define freewheeling current to the seconds since freewheeling start divided by freewheeling start seconds. So if my freewheeling start seconds, freewheeling ramp seconds is what we want right here. We gotta pay attention to what we name our variables, boys. Okay? So if the freewheeling ramp seconds is 0.5, half of a second, and then we get that seconds since freewheeling start. So that could be less than half of a second, right? So let's say it's 0.1 of a second. So if you do 0.1 divided by 0.5, so that would be 0.2, right? 20% current. So we're going to have a fraction in this freewheeling current, but really, I'm going to name this rel. So it's like represented as like a relative current. So then I'm going to update that reference right here. This variable, it's going to hold that relative current. So between 0 and 1, we're going to multiply that by the freewheeling current that we want to apply. So I'm going to refactor this a little bit. I'm going to change minimum current. So I'm going to leave this freewheeling current relative max. I'm going to leave this up here because it is something that you kind of want to configure. It's related to freewheeling, but so this I'm going to put up here too because this is more related to a configuration value. These are state. Okay. All right. So we've changed some things. So I need to come down here to this code right here and continue working on this. Okay, so this freewheeling current relative. So then we're going to define. So now I'm just going to multiply that. So define freewheeling. Well, I guess I could just do it all in one expression here. I don't know if I want to do that. I'm just going to do this. So freewheeling current rel. Okay. So when it runs this first line, it's going to divide the seconds since the freewheeling started by the freewheeling ramp seconds. So that could be it could be 0, it could be 1, or it could be more than 1. And then so that's going to be in here, and then we're going to multiply that by that current relative max right here to kind of figure out how much current are we actually applying right now, based on this relative current multiplied by this, this maximum relative current that we want the freewheeling to do. Right, so then now we should be able to say we're going to set the current rel and we're going to do freewheeling current rel. So I refactored this. Let's go out into the garage. Oh my god, how did this video take 35 minutes? Oh boy. Let's go into the garage and see how this works. Oh my god. Okay, so we're out in the garage with the computer. We've got the USB cable connected to my flip ski, which is up in my do-it-yourself danger battery box. So we're looking at, we got my script. Okay, so what I'm going to do is right now, I had previously uploaded a script onto the flash on the VESC. So that's persistent and starts the code on every boot. So I'm going to erase that. Okay, first we got to connect. So I'm going to go back up. Since I'm connected, we can just go up to the top right, click on reconnect. Okay, there we go. So now we're connected. So I would say when you're using a computer, I would use the USB cable, okay? Because Bluetooth, I would use Bluetooth on your phone or whatever you use, like when you're riding your bike, because you don't want to have to keep pairing and unpairing Bluetooth on different devices. It's a nightmare. Okay, so I would on your computer, use the USB cable. Works a lot better. Then you can keep it paired on your phone or whatever with Bluetooth, and you don't have to mess with that. Okay, so I'm gonna, back to what I was saying. We erased the script right here, erase. All right, so erasing old script. All right, so it erased it. So now what I'm gonna do is we're gonna upload, or no, we're not gonna upload, we're gonna stream it. All right, so that streams the code. This is faster and not persistent, but does not work with imports. I'm not doing any imports, so we're gonna stream. Boop. All right, so there's a problem. So there's some kind of a line 76. Something terrible has happened. All right. Seems like I forgot a few parentheses in the expressions up here that I was doing when I was defining all of these variables in the apply current function. So I'll leave a paste bin when I upload the video of the script. Okay, so I think I fixed that, so let's stream that. Is that gonna work now? So it's a stream done, starting. Okay, so I'm gonna click up here on poll status, and then now we can see that it's doing something. It's reading the throttle value. Okay, so the script is going. Script is running. Let's close that magnifier. Get out of here. Okay, so let's see what happens. So when I hit the throttle, it should start freewheeling, but it's gonna like ramp it up. I hope. I'm gonna actually add a little safeguard to the code here quickly, right? Just a little bit of extra code. Alright guys, so in the supply current function, it's going to check if the freewheeling current relative is greater than the freewheeling current relative max, then it's going to clamp that value. It's going to set the freewheeling current relative to the max. So it should not allow that value that we calculate here to become greater than that value that we've set for the maximum. So it's just a safeguard to make sure that nothing crazy happens. All right, so I want to upload that. We're gonna stream it. All right, so that's running. Now let's hit the throttle and we'll watch how this ramps up. So it should ramp up over half a second. Is that what I did? Let's see. Oh, what happened there? Oh, that's crazy. It's getting some crazy numbers here. What is going on here? Let's see. Let's make it ramp up slower so I can see what's going on here. Freewheeling, I'm gonna change the freewheeling ramp seconds to 1. Stream it. Okay. So I'm gonna gently hit the throttle. Slowly. Oh. So doesn't seem like freewheeling is even going here. What's going on? Okay guys, so we're just discovering things very quickly here. So it seems like I've wanted to find like a minimum for the freewheeling current and then like a maximum for the freewheeling current. Because if you're giving a freewheeling current but it's like not enough to spin the motor, then it does funny things. So back at the top here, I've defined freewheeling current relative minimum and then freewheeling current relative maximum. So when the freewheeling starts, it'll start out at the minimum and then it'll ramp up to the maximum over the ramp seconds. Okay. So let's see. So I've updated the script to kind of make sure that when the freewheeling starts, it's going to be doing a little bit more current than I had previously. Let's see. Oh, there we go. Look at that. So it says the motor is going at like 10,000 RPM, ERPM. So let's give it some juice here. Oh, all right. So let's start it up again. Let's see. Let's get some slack in the drivetrain here. Spin the wheel a little bit. Get some slack. Um. All right. So I think the freewheeling starts up a little bit smoother now instead of just all of a sudden giving it just a flat current when the freewheeling starts. Now it's starting out at like 0.1 relative current and then ramping it up to what we have set for the max. It's hard to like. Let's see. Can I just start it up over 2 seconds? Maybe we can slow it down even more. It was kind of hard to witness the ramping. Let's stream that. I changed it to 2 seconds ramp time. All right, there we go. So that seems to be working a lot better. It's just kind of doing like a linear, ramp based on how many seconds it's been since freewheeling started. Starts out at that minimum relative current, and then the freewheeling should go up to that maximum current that we've set. So let's increase the maximum current a little bit, like to point. So one thing that's funny is on my flip ski, when I'm calling the set current relative function, it's supposed to be part of VESC, but it's just like I'm passing in this freewheeling current relative, and like I don't think that this set current relative function is working properly on my VESC firmware that's on my flip ski. So if you try running this script and you're on a different VESC or like a updated flip ski, like you got to be careful about what you're passing into the set current relative function, because my understanding is it's supposed to be like based on the maximum power that you have the battery set to. And so like I'm passing it in like a pretty big number, it seems like, but it like that's just what I'm doing because that seems to be, I don't know. So what I'm saying is set current rel, this function in scripting on my flipski is working funny. So be careful what you pass into this thing. Be careful if you use this script. Be careful what you use for this max. Like change this to like 0.2, okay? Instead of what I have, 0.7, because that's 0.7. That's supposed to be 70% of your like the full power, which is a lot. But like you can tell when I do freewheeling and I call set current rel, I'm passing in 0.7. So it's it'll be freewheeling, but it's not doing 70% of my bike's power, right? Because when I hit the throttle, it's more power. So something's working weird with my flipski VESC scripting. All right, well that's this video. I wanted it so that when the freewheeling started, it would kind of like ramp up the freewheeling power instead of how I had it previously in the video the other day, where when freewheeling started, it was just boop, like it just instantly applied the full freewheeling current and there wasn't like a ramping of power. Okay, so like and subscribe, leave a comment. Just wanted to run you guys through a little bit of scripting with this Lisp scripting language and VESC, and show you guys how I'm working on this script to get the BBSHD running smoothly with VESC. So follow along as I continue scripting my e-bike with VESC. If you want a flip ski, check down in the comments. I got a link to their website where you can buy one. Use the code EBB at flipski.net and you get $10 off. It ends up being cheaper than Amazon. If you go to flipski.net, you get the 75-100 Pro V2. Use the code EBB. I'll put a link in the description. And I don't, you might even get an even bigger discount. I don't know. But if you use my link in the description, just do it. Just do it. That'll help the channel out. Thanks, guys. Appreciate it. Like and subscribe. I'm going to keep working on this script. We're going to keep going. We're going to keep making it better and better. Let me know your thoughts in the comments. What should I do next with scripting and VESC? Peace out, bubbies. Later.